And hello everyone, welcome back. So this time we're learning about amount and Avogadro. Not avocado, Avogadro. Okay, maybe you didn't see the avocado thing there, but I definitely do every time I hear his name. So what is this about? Let's have a little bit of an overview for this because this is an important concept that's kind of just glossed over in your textbook. In all things in life, at least when it comes to chemistry, actually just everything in your life, that you can see, feel, touch happens because of some microscopic, some nanoscale reactions. Like, for example, touch. You touch something, but in actuality, you're not actually touching anything. What's happening is there are electrons in both sides of your fingers. And when those get close enough together, they repel. And that's what's causing the force that you feel as touch. So when you're pressing, there's actually a gap there because those electrons are just pushing against each other and keeping from touching. So you never actually touch anything. Magic. But anything else, most things that you know about are from microscopic relationships, like ice being slippery. It's because when you look at the very, very fine microscopic scale, what you see is that when you press down on ice, the very top layer becomes water, which means it gets very, very slippery because the water is able to move and flow, and your foot will flow with it. Slippery. Anti-glare glass, that happens because of microscopic little structures that are on top of the glass. You can't see them and that glass feels perfectly smooth, but it's not. On those nanoscale, that's like times 10 or divided by a billion, it is very textured. So there are these relationships and they lead to the macroscopic properties that we know and love. Another way just to think about this to really give it to mind. Think about looking at Earth from space. When you look at Earth from space, it looks incredibly smooth. However, when you get down to the surface, you see that there are valleys, that there are mountains, that there is water, there are trees, there's all this stuff going on. But from a far scale, it all looks smooth. But just because it looks smooth from a far away scale, from a big scale, does not mean that those microscopic relationships don't matter. So when we're doing chemistry, when we're doing engineering, we need some way to be able to convert from the microscopic scale, which is what we see right here, where we have atoms, molecules, electrons, protons, that kind of stuff, over to the macroscopic scale, which is what we normally see, and vice versa. We need to have a way to go between both of them. It's very important. And so Amedeo Avogadro, we're going to learn about next time, is the guy who gave this to us. So I hope you found this interesting. This is just an intro to amount. And also, when I call it amount, it's because we're going to learn about a number, Avogadro's number. And it's just a number. Just like dozen means 12, or baker's dozen means 13, a couple means 2. There's lots of different words we use for different numbers. And this one is just another special one that we have to memorize. Or put down in your textbook, or put down in your notes. Put it somewhere. I don't make you... none of the quizzes in this class are closed notes, so put it down somewhere you can reference it. Okay, with that, I'll see all of you next time. Bye-bye.